there's something called hypothesis testing. So I told you many times when we do a inferential statistics, we want to also make sure that the sample we have taken is really part of that population, right? So that is one thing for which you do hypothesis testing to check whether this is really part of the population. The other thing is, suppose you are having a thesis, right? You have a hypothesis. You have a thesis or a theorem or something, and you are saying something which is against the current understanding of people, right? So you have say you have a new theorem or a thesis and you want to prove that, right? So if you have enough evidence or proof, then an alternative hypothesis will be taken. That means your any current prevailing theory about that thing might be discarded and your theory might be accepted. This is very much happens in the research thing, right? So suppose somebody comes up with a new way of somebody comes up with a new law on gravitation, and he says that this Newton's laws are not correct, my law is better, right? Or I can explain gravitation better than Newton, right? For example, so he brings his thesis and says, no, gravitation does not work like this, gravitation works like this, and he has his own thesis. Then he has to have enough evidence to prove that to the scientific community that, so the null hypothesis is that his theory is not correct, Newton's theory is correct, but the alternative hypothesis is that his theory is correct and we have to reject the null which is Newton's theory, right? So in that case, he has to have enough evidence to prove to the scientific community that his theory is correct, and then they will accept that as a new theory, and then it will get accepted by the communities, all the scientific bodies, and then it will become a new theorem, right? So till that time, you have to accept the null hypothesis. This is, I told you about the classic example of a court of law. In a court of law, basically, a person is innocent until proven guilty, right? So the null hypothesis is anytime whenever you are trying something, some trial, a person is innocent is the null hypothesis. But if the prosecution has enough evidence to prove otherwise, if they have enough evidence, then the alternative hypothesis that he is guilty will be accepted. Till then, null hypothesis remains in action. Yeah, we had talked about all this. This is just for the some of the people who might have missed this, right? Very important in hypothesis, we want to avoid type 1 error. There are two types of errors. Type 1 is alpha error and type 2 is beta error. A lot of time, type 1 error is something you want to avoid. So a p-value is something which is basically the probability of having that error, right? The p-value is the probability of having that error. So that should be as low as possible, okay? So whenever you're trying to prove something new, your p-value should be very, very low, so that the chance of your whatever you're trying to prove going wrong is very low. If your p-value is very low, then your thing will be accepted as the alternate hypothesis will be accepted. Otherwise, the current situation will remain in vogue. So alpha is type 1 error. Alpha 2 is type 2 error. So type 1 error is when you are actually rejecting a null, whereas it should be you should have accepted the null, right? So in case of a court of law, you're rejecting the null. Null means what? The person is innocent, right? So you have rejected the null and you have put him in jail. So you have put an innocent person in jail is a type 1 error, right? A type 2 error is you have actually failed to reject the null. Basically, that means you have accepted the alternate hypothesis, right? You fail to reject the null, or not fail to reject the null basically means, you're not rejected the null, right? You're not rejected the null means you failed to, while actually the truth is that H0 is false, right? So your null value is wrong. That means he was not innocent, he was guilty, but he was let go. That is a fail to reject. So it's a type 2 error. So a person who was guilty was let go by court. It's a type 2 error. An innocent person was put into jail. It's a type 1 error. Okay. most of the times we try to avoid the type 1 error, right? So every time you do the p-value, you try to find out where the p-value is should be a very low value. So normally in most of the business cases, 95% confidence levels are accepted. So 95% and 5% error margins are allowed. So 5% is actually, it translates to 0.05 probability values, right? So 0.05 is the probability value. So whenever is your p-value less than 0.05, that means, whatever you are saying, whatever alternative you have proposed is, true. That means you have enough evidence to prove, or the data is showing you enough evidence that you should accept the alternate and you should reject the null, right? Okay. So whenever there is a p-value which is less than 0.05, you will reject the null and accept the alternate. Whenever the value is 0.05 or above, you will say the null remains in vogue, or you will reject the alternate or reject the alternate hypothesis, and you will accept the null. Okay. So when we are running some data, you will see that. Okay, you will see you run some programs, you will see that it runs a statistics and it gives you a p-value. And once you have that p-value, based on that, if it is less than 0.05, you will reject the null and accept the alternate. If it is greater than 0.05, you will accept the null or you will reject the alternate. Okay. The way I remember it is that if p is low, the null must go. Okay. That means if p is low, means if it is less than 0.05, the null must go. Null must go means alternate must be accepted. Okay. When your null goes, what remains? Alternate remains. Okay. Alternate goes, basically what remains is null, right?